More knowledge, more problems. Here it comes. So we talked about angle, elevation, depression, how supplementary angles are going to be helpful to get us an angle inside the triangle. We talked about guy wires. We actually solved one of the word problems, and I kind of added a D part to it, right? How far from the base of the antenna is wire 1 anchored? When you anchor something, you put it down on the ground, right? So we also figured out this little sliver here. So we'll continue with that. The most challenging part is going to be drawing your triangle, of course, not necessarily solving. Okay, so let's go over to page 20 here. Okay, so scary moment, guys. I want you to read it. Don't do it right here. Somewhere on the side here. Maybe even over here. Try to sketch, try to read this and come up with a sketch. I don't really, honestly, right now, if you get it wrong, not a big deal. But try to read this, right? And picture it right here. And then if you want to erase it later, sure, go for it. But right here, use this space to read and make your diagram, put the numbers where they belong. And then I'll come back and I'll do the whole thing with you, okay? I don't want you to solve anything, just try it. Let's see. Grab your highlighters if you have them. Amanda is enjoying a hot air balloon ride over Winnipeg at an altitude of 2,500 feet. Altitude is height, okay? Same thing. Height above ground. She spots the forks at an angle of depression. Oh, there's that angle of depression, right? Of 34 degrees. At the same time, she spots Winnipeg's tallest building, the Artist Reed building, at an angle of depression of 27 degrees. Okay. Sketch the scenario, include all labels and measurements. So you have to imagine, right? The hot air balloon ride is somewhere up here. And there will be the ground as your reference, right? And so what we know for sure is that the hot air balloon, we can call that H, right? We know that the height to the ground, right, it makes a 90. We know that that's 2,500 feet. This height might travel with us later somewhere else, but we know that the height stays 2,500 feet. Okay. And so from up there, the first building that is being noticed is the forks, right, or the first place, right? And we'll just make it right on the ground here. And the angle of depression is 34 degrees. So this is what's important here. Remember that for an angle of depression or elevation, there needs to be a horizontal line to measure it. Okay, so you kind of have to imagine that there's a horizontal line up here, right? And from there, it's measured that this is forks, right? That angle right there is 34 degrees. Okay, that's what is being talked about there as being 34 degrees. And so from up there, the next building being noticed, right, is at probably somewhere a little further down, and we'll call that A for Artist Reed building, right? And I'm going to use my ruler for this, if I can find it. There it is. We know that thou is 27 degrees. Okay, so we're going to cut through that angle that we just created. Okay, and so this right here, I'm going to make the arc a little further away. That's 27 degrees. Right? Remember that we have our horizontal here. Okay. On page 20. And now this is something you have to get used to, erasing, okay? So for example, this 34 doesn't look very good right there. So I will actually do this, right? Complete my diagram and then just make sure that this is 34 for me. So I'll actually mark that this whole angle right here is 34 degrees. Okay. And the 27 is just that smaller one that's created right there. Okay, that's 27. So this would be the diagram. This is what the story is trying to say. Okay. And notice that there's nothing, we're not told that there's a height to these structures or anything like that. So we're just assuming, you know, when you're that high up, right? We're just interested in perhaps a distance between them, right? And so forth. But this is the diagram. We have labels. We have every angle is labeled. We've got our height here, 2,500 feet of the hot air balloon. We call that H. Okay. And now we can start solving for things. Okay. Calculate the direct distance between Amanda and the forks. We'll call this H here. Amanda is the hot air balloon, right? And the forks, which we called F. So we want to know this distance here. So let's call that X. Okay. We're going to put a little bracket here and saying, hey, they're asking us to figure out the distance between Amanda and the forks, the direct distance. So what can we do there? How is that possible to solve? And I'm going to tell you this. This height here, right, it can travel with you wherever you are. Like you can bring it over here and actually complete the height here if you want. Okay. And so let's go ahead and do that. I'm going to do this. And this horizontal length is coming with me here. And there's your 90. And this is 2,500. Okay. It's very important that you notice that, right? That this height, right, it doesn't change, right? Like wherever you go, that stays the same. So for B, I'm trying to solve B right there. I'm going to draw my triangle like this. I know that this is 2,500 feet. And notice that I put a right angle here because, yes, the horizontal line up there, if it's a horizontal line, it's the same as the ground, right? They are parallel. Remember that from geometry? Parallel, that line is parallel to this line. These are parallel lines right there. So we can also, what angle are we going to put in here? The 27 or the 34? If you look at this side, like if this is the side you're following, right, then it's the 34 that comes in here. There you go, 34 is right there, and this is side X. And lo and behold, you have a right triangle, you have a pair right there. So pair, sine law, right? Pair, sine law. So let's go ahead and do that. Sine of 34 over 2,500. In the previous years, you would have used SOHCAHTOA here. Okay. Sine of 90 over X. Okay. So I can cross multiply and divide, right? So X is equal to 2,500 times sine of 90, which we know by now is just 1. And there we go. 2500. I'm just going to go ahead and divide it by sine of 34. I'm not even going to bother multiplying it. So that's 4470.73. 4,470.73. And we're talking feet here. So that is the answer, right? Direct distance between Amanda and Forks. There you have it. I'm going to suggest something, maybe that's going to take you back, right, to chapter 2. Is 34, what would be called 34, this angle here and this angle here? If you know that there are two parallel lines, alternate, interior, so you could have brought it down here. And then just, but it's the same triangle, right? You would have ended up with a flipped triangle, same thing. So if you see that, go ahead, you can do that. Feel free to do that. I just didn't want to traumatize you early in the morning with alternate interior angles, right? But it's there. And remember, the height always follows you anywhere on that diagram, right? It's always the same. Please also remember, I will actually do this because it happens often enough. So this is a common mistake. Angle of depression of 34, right? If it's 34 degrees, a lot of students will do this. Yeah, there's the Forks, and they'll put 34 here. And that's not going to be you. You're not going to be that student, right? But it's not there. It always goes between the horizontal, right? This is 34 right here. That's where it goes. And that's something important to remember, because it's wrong. Like, your diagram will be off if you don't. So this is a very common error. You're not going to make that mistake. You're going to insert a horizontal line and then measure it from that horizontal line going down. Okay. All right, let's do C here. Question C. What is it asking us? It's asking us to determine the distance between the two spots. It's basically asking for FA, right? It's asking for this. Let's call that Y in particular. I don't know. I don't like two-letter notation, so that's going to be our Y right there. Okay. Keep in mind, I could have jumped straight to it, but instead I kind of stopped at B and we solved for this side here. But you might have had to do it anyways to get to this, because now, carefully, I would strongly encourage you to do that. Let's draw out what we have so far. If we just take out this one right here, right, this triangle right here, where this is X, this is Y, and what do I know about this triangle in terms of angles? There's a couple of ways of doing this. Couple of ways of doing this. Okay, are you ready? Is there a way I could find this angle right here? This part right here. It's just this part. It's not 34, is it? This is not 34, because watch, I cut this out here, right? This is the triangle I'm using here. So to get that one, I would go 34 minus 27. Do you follow that? On a Tuesday morning, right? And that's 7 degrees. Okay? It's not 27, it's not 34, it is the difference between the two. Okay? Allow me to This angle right here, if you want to put it, it's basically just this little sliver here. Okay? Just that little sliver. That's 34. 7, sorry, 7. What else do I know about this one? I just figured out x, right? So I'm actually going to say, hey, I know this, 44, 70, 73. That's straight. I don't want to go arrow because I might you need that space yet. Is it? Can I work with two things in a triangle? You need at least three things. Yes, you need at least three things. So what else can I do here? This is where you need to use chapter 2 to help you out. Is there a way, right, that I can possibly maybe get this angle here? Like if I talk about I just talked about that this is what? This is 34. You brought it down here. So this is 34 degrees. And I'm going to tell you how I got that, right? Alternate interior angles, right, are congruent. There's other ways of doing it, and if you see it, way to go, right? You're doing, that's what I, and then this angle, now I can find that one, right? This is actually F right here. If you copy it with you, so angle F is 180 minus 34, which is 146 degrees. So now you know that this is 146. Now you have three things. Now you're good to go. All right? This is angle A. Let's stop here for a bit. There's a lot of stuff going on. So do this with me. I did this first. Then I figured out this part. It was my second step. Then I figured out angle F. They're supplementary, right? Supplementary angles. And now I'm going to do the fourth step, which is finding this angle here, right? Because once you have two angles, you can find a third. So it's just like a chain reaction, right? So 4 angle A is equal to 180 minus 7 minus 146. And that is, and you're going to see this number somewhere else. Do you recognize 27? Where else do you see 27? It's right up here. So how could we have used alternate interior as well here? Yes, because the parallel line is, so there are many ways to get your answers over, but it's all connected, it all jives, okay? Everything is connected that we're doing here. So this is step number 4. So let's put 27 in there as well. This is a, by the way, guys, this is a crazy example, okay? I did it on purpose. I wanted the example to have lots of steps. So some of the ones you're going to be working on are not going to be this intense, okay? Most of them, I would say. All right, let's see what we can do here now. I have my pair, this and this, right? These are paired up. So solve for y. Sine of 27 degrees over 4,473, okay, is equal to, what is it that they want us to find? They want us to find y, so I need to use this 7 degree up here. So I do that, and I expect the distance to be smaller, right? Because it's a very small angle, so I expect it to be smaller. 44, 70, 73 times sine of 7 degrees. Let me just bring that up a bit. Now you know why this whole page was empty, right? Because there's just a lot of stuff going on here. And so y is equal to, I will just get you the answer. Because by now we know how to type that in, right? Distance between forks and artist reach. Okay. So if you sit down and you make if your diagram is done well, you should be able to transfer stuff over, okay? And you cut and slice and you make sure you're consistent, then that's when you're going to build success. All right. Okay. I'm going to go to the textbook. I'm not going to assign this one, so I'm just going to ask you to copy it on that page 21 there. We're going to do one more, a less intense question, perhaps. So you have one with angle of elevation. We did that yesterday, right, with the guy wires. And you have one with angle of depression, right? And now we're going to do another one here. So I'm going to copy it straight from the textbook. So here it goes. You write the question down because I think I will change it a little bit. Here. This is actually, let's write down page 148, question 8. Okay. Fred and Agnes are 520 meters apart. As Brandon flies overhead in a plane they estimate that the angle, can I just do this, angle of elevation, right, is 60 degrees for Fred and 40 degrees for Agnes. Assume the plane, I'm changing it a little bit, the plane is between the two. That assumption is not stated by the word problem. Calculate the height of the plane. I think that's jumping too much. So we'll first do the distance between Agnes and the plane, and and then B, the height of the plane. Technically, I could have jumped straight to the height of the plane, but I'm going to guide you through it a little bit with A, right? Make a diagram. That's where you come in right now. Just read it and see. And before we dive into this, I'm just going to already tell you what the homework is. Okay? If you look at the bottom here, this is from the textbook. And I'm sending you to the obtuse triangle section. Okay? I would say focus on the word problems. These are just the 1 to 5, they all provide you diagrams, so it's actually fairly straightforward. Like you know how to do that. If you were able to do the first AC, like the AC questions we did today, you're fine. So just focus on the word problems, right? In particular. And obtuse or cute doesn't matter. There's only one problem down the road, and I'll talk about that later on. Okay, so we have angle of elevation. Safe to say you're on the ground. Okay, so this is your diagram here. We've got Fred and we've got Agnes here, and the plane is somewhere in between them. But you know it's not right in the middle, do you? Right? One of them is looking up higher. So Fred, actually, the plane is probably somewhere in here. Call that plane, right? So the angle of elevation is between the horizontal and the line looking up. So that's your 60 there. And Agnes is probably further away because there's a smaller angle of elevation. So this is 40 here. And we know that the distance between them is 520 meters, right? I will do this already because this is going to throw you off. If I give you a diagram with that right off the bat, that's going to throw you off. Some students don't see the big triangle. They're stuck on this, right? We're just going to ignore it for now and just deal with the full triangle. We want to figure out the distance between Agnes and the plane. Agnes and plane is right here, so we're going to call that X. And then this we're going to call H. Right? That's what the question is asking us for. I'm looking at this. It's definitely not SAS. It's most definitely not SSS. So it's not cosine law. So it's a hidden pair. Remember that? It's the couple that hasn't announced it yet that they're a couple. You know what I mean? 180 minus 60 minus 40. That's actually a nice 80, right? 100. 60 and 40 is 100. So I'm not going to circle that because that's just part of what I need. But there you have your pair now. Okay. So sine of 80 over 520, okay, is equal to what angle am I going to have to pick? It's counterintuitive, but if I want X, I'm going to pick that angle right there. And I'm going to, that's X for me. So 520 times sine of 60. See that this one isn't as crazy, right? I scare you a little bit with the examples because I want you to be ready to tackle that, right? Something to go back and check, right? And so we've got, I need to figure this out because sine of 60 divided by sine of 80, that's 457.28. The book doesn't ask for this. And so that's in meters. That answers A, right? That answers A for sure. And now I'm going to find the height. I hope you would know how to do this by now. How would you find the height in this particular case? Can you say it louder? Or this times sine of this? Okay, perfect. So it would be X times sine of A, right? Just telling myself what it is that I'm doing. I happen to know this side. I don't know this one. I could find it. I'm not going to bother. So it's just 457.28 times sine of 40 degrees. You got it. I still have this on the side on my calculator, so I'm just going to go times sine of 40, and that's 293.93, and we're in meters. If you, this question could have easily asked, right, for the distance between a Fred and the plane, right? If you knew that one, you would go this times sine of 60 to get your height, right? So you got to be smart about it. And that's it for today, guys.